The data is weight of defensive tackles in the National Football League. The analysis will be repeated for weight in kilograms, pounds, and stone. This is weight in kilograms of 100 defensive tackles in the National Football League. The minimum is 124.1 kilograms. The maximum is 155.9 kilograms, and the range is 31.8 kilograms. Since this is weight of people, a class width of 5 is reasonable. With width 5, there are 7 classes, with an average of 14 observations per class. The first class can begin at 121 and end at 125 to accommodate the 2 lowest observations. Starting at 121 with class width 5, the class limits are as shown. Notice that although the class width is 5, the difference between a class upper limit and lower limit is 4. The 121 to 125 class will have values 121, 122, 123, 124, and 125. Since there is 1 decimal, the class boundaries must separate the classes to 1 decimal place. The boundaries can be as shown. This is the frequency distribution with the given class limits and boundaries. Possible midpoints for each class are the upper class limits. These will be overestimates, but still representative. Averaging successive lower class limits produces fractional values, like 123.5, which should be avoided to minimize confusion. Perhaps a better midpoint would be the average of the lower and upper class limits, like 123 for the lowest class. The possible midpoints and the actual average by class are shown in the table. One way to evaluate possible midpoints is to compare the actual average of the original data to the weighted average for each type of midpoint. In this case, the average of the 100 observations is 138.2 kilograms. The weighted average for the upper limit midpoints is 140.2. For the average of successive lower limits, the average is 138.7. And for the average of lower and upper class limits, the average is 138.2. From this standpoint, the midpoints from the average of the lower and upper class limits is best. This is the same weight data with weight in pounds, with no decimal places. The smallest and largest observations are 273 pounds and 343 pounds, with a range of 70 pounds. A reasonable class width for pounds is 5 or 10, as it was for weight in kilograms. A class width of 5 would have 14 or 15 classes. A better width is 10. Since there is no 0 in the data, the lowest class can begin at 270 or 271. Purely for variety, the first class will begin at 271. The class boundaries can coincide with the class limits. The frequency distribution with convenient midpoints is as shown. This is the same weight data with weight in stone, with 1 decimal place. The smallest and largest observations are 19.5 stone and 24.5 stone, with a range of 5 stone. Class width should be 1, with classes 19, 20, 21, 22, 23, 24, or 20, 21, 22, 23, 24, and 25, depending on the chosen class boundaries. Convenient class boundaries are from x.0 below to x.9 above. Also, the class values can be used as the class midpoints. With these class limits and boundaries, the frequency distribution is as shown. For comparison, these are the histograms from each weight type.